Hey everyone, welcome back. So this question was actually given to me by one of my students, and it was quite challenging, just a little bit challenging. So I thought I would just come on here and share the solution with you guys. Okay, so let's get started. It says use mathematical induction to prove that 7 to the power n plus 3 to the power n minus 1 is divisible by 4 for all integers n greater than or equal to 1. Okay, so when you're proving using mathematical induction, there's three things you need to take into consideration. So the first thing would be to prove that n equal to 1 is true. That's step one. So what we're going to do is basically substitute n equal to 1 into the formula, 7 to the power n plus 3 to the power n minus 1, and show that it is divisible by 4. So when n equal to 1, this would imply we'll have 7 to the power 1 plus 3 to the power 1 minus 1. And this would give us 7 plus 3 to the power 0, and that is obviously 8. So now 8 is divisible by 4, since 8 divided by 4 is equal to 2. Pardon me. Okay, that's the first thing you do. Now, we are going to assume that n equal to k is true. So whenever we substitute k into this equation, it should be divisible by 4. Now, this would mean we'll have 7 to the power k plus 3 to the power k minus 1. And if it's divisible by 4, it means it can be written as a multiple of 4. So it means that this whole term has to be equal to 4 times something. We can just call that something a g, where the g has to be greater than or equal to 1. Okay, so I've just defined it right there. Okay, now that we assume that k is true, what we're going to do next is prove that n equal to k plus 1 is also true. Okay, so I'm just going to reduce the size of this. And let's go ahead. So we're just going to have 7 to the power k plus 1 plus 3 to the power k plus 1 brackets minus 1. And then if I simplify this, I'll have 7 to the power k plus 1 plus 3 to the power k plus a 0. So it'll just be 3 to the power k. Okay, now the thing here is we have to use our second step to prove the third step. So what we do now is we have to make 3 to the power k in this equation that we got before, so that we can substitute it in here. Now the point of step 3 is to always rearrange the equation in such a way that you will be able to factorize 4 out of it. So if you can factorize 4 out of it, it means we're actually able to prove that the expression is divisible by 4. So we're just going to go ahead and make 3 to the power k the subject of the formula right here. So we have 7 to the power k. Let me reduce this. 7 to the power k plus 3 to the power k minus 1 equal to 4g. So now I'm just going to take 7 to the power k to the other side of the equation. This would be 3 to the power k minus 1 equal to 4g minus 7 to the power k. And then we can actually separate this into 3 to the power k times 3 to the power negative 1 equal to 4g minus 7 to the power k. And then 3 to the power negative 1 can be written as 1 over 3. So this is the same as 3 to the power k over 3 equal to 4g minus 7 to the power of k. Okay, so 3 to the power k would just be 3 times 4g minus 7 to the power k. Okay, now we're just going to go ahead and replace this in our expression. So this would be 7 to the power k plus 1 plus 3 times 4g minus 7 to the power k. Okay, so I'm just going to expand the brackets using the distributive property. So this will be 3 times 4g minus 3 times 7 to the power k. Okay, 7 to the power k plus 1 can also be written as 7 to the power k times 7 to the power 1 plus 3 times 4g minus 3 times 7 to the power k. And then we're going to factorize 7 to the power k in these two terms. So this will be 7 to the power k times 7 minus 3 plus 3 times 4g. Oh, there's supposed to be a g over here. Okay. Now, lastly, we can see that 7 minus 3 is 4. So this will be 4 times 7 to the power k plus 4g times 3. And then if we factorize 4 out of this expression, we would have 4 into 7 to the power k plus 3g. And since we can write this as a multiple of 4, it means that the expression 7 to the power n plus 3 to the power n minus 1 is actually divisible by 4. That's it for today's video, guys. If you found this video useful, just give me a like and share with your friends. Thank you.